Very good morning, dear children. So, as we have completed coordinate geometry in the previous lecture, now we are heading to the next chapter of the coordinate geometry, that is distance formula. Okay, so in the previous chapter we have seen how to locate the points and also how to plot the points formed by the linear equations. And we have also seen that how to solve the two linear equation using graphical method. Alright, so in the distance formula we will be discussing about the formula which is like to find the distance between the two coordinates or the 2 points. Say for example, in the graph, if I have these 2 points, say x1 y1 for this point P, and let us consider this as Q and give the coordinate as x2 y2. And if I want to know the distance between these 2 points, so by graphical method it is quite easy to calculate because with the help of the scale we can find. But if we want to solve it algebraically, we have one specified formula that how to find the distance between these 2 points. So PQ is given by x1 minus x2 the whole square plus y1 minus y2 the whole square. That means if you take the difference of the x coordinates and square it plus difference of the y coordinate and square it, you will get the distance between point P and Q. Actually, we understand in this we have used the application of Pythagoras theorem. Actually, we consider these 2 points as a hypotenuse, and if I make a straight line here and straight line here, it makes a 90-degree angle. Okay, and actually this is explained like this. If we consider this as y1, this as y2, and this is x1 and this is x2, then we know how to find this distance, x2 minus x1. If this is, say for example, 1 and if this is 4, then we can find this distance. It will be 3 only. Okay, 2, 3 and 4, so 3 centimeter. So that like that, this distance will be x2 minus x1 or x1 minus x2. They are same. You know, this formula can be written as like this also, x2 minus x1 the whole square plus y2 minus y1 the whole square. But make sure that if you are no problem, x1 minus x2 the whole square plus y1 minus y2 the whole square, or it can be under root of x2 minus x1 the whole square plus y1 minus y2 the whole square. So this distance is x2 minus x1 the whole square. This distance is y2 minus y1. Okay, sorry, this is x2 minus x1, this is y2 minus y1. We can easily find the hypotenuse by the application of Pythagoras theorem. This square plus this square is equal to this square. Okay, so square was there, actually we cancel the square and root will be here. So that is how the distance formula came. Okay, there are some properties for the like distance properties in some geometrical figures. Like say for example, if you are given 4 points and you need to prove that this 4 points are making a square, when you enclose this structure you will get a square. So we know the property of square. What is the property of square? All sides are equal and diagonals are also separately, they both are equal. Okay, so by help of the distance formula we will be given this 4 points. So we'll find AB, then BC, then CD, AD, AC and BD, and by their distances we will use the property of the particular. Similarly for the triangle, for the isosceles triangle, these two are same, so we'll find the distance between these 2 points, these 2 points and these 2 points. For equilateral triangle, all are equal. Similarly, like for the quadrilateral, for that is basically the parallelogram, opposite sides are parallel. For the rhombus, for the rectangle, for the square, okay, like that, by using the property we can distinguish whether the points make which quadrilateral or whatever they are asking. Okay, now next comes the collinear condition for the collinearity. Condition of collinearity. of points. What do you mean by collinear points? I have explained you in I guess previously I've explained you what are the collinear points. Say for example A, B and C. If they are lying on the same line, then that A, B, C are called the collinear points. Okay, so if three points are lying on the same line, then A, B, C are called collinear points. How can you prove that this ABC are collinear point? So just find the distance between AB, BC and AC. AB, BC and AC. So we know AB distance plus BC distance must have to be equal to AC distance. Okay, so if this happens, then we can say ABC are collinear point. Understood? So that's it for the basic part. Now we have to head to the exercise. Okay, all right. Okay, question number exercise 2a, question number first, C1 I'm doing. I'm reading the question. Find the distance between the following pairs of a point. Calculate correct to three significant figures. This means if you have in the under root, then you have to calculate for three significant figures, means after decimal three numbers should be there. Okay, three figures should be there. So this is the pair of the points. We know by using distance formula we can calculate the distance between these two. So x1 minus x2 the whole square plus y1 minus y2 the whole square in the whole under root. So under root, this is x1, this is y1, this is x2, this is y2. So 1 minus 1 upon 3 the whole square plus half minus 1 upon 4 the whole square. So on taking LCM, 3 minus 1, 2 upon 3 the whole square plus minus it will be plus. We know half plus 1 by 4. Usually you get marks. So how do you add half and 1/4? It is actually 1/3/4. Okay, so you can understand like that, or just take LCM, will get 3 by 4 only whole square. So it is 4 by 9 plus this will be 9 by 16. On taking LCM, I'm getting root 145 upon 144. So 144 can be taken out as 12, and this you keep it as it is 145, or else if you want you can just take the root of it. Okay, and just divide, you will get the answer in the point. Okay, coming to the next question, it says find the distance between the points P on the x-axis and Q on the y-axis, where OP is equal to 6 centimeter and OQ is equal to 8 centimeter and O is the origin. Use distance formula to find PQ. Okay, so let us do this thing. Okay, so we are starting with, as P is on x-axis and OP is equal to 6 centimeter. If you want to see this in graph, it is actually OP. This is O, and we are considering P on x-axis. So P will be on x-axis and OP is how much? 6 centimeter. So this distance is 6 centimeter, and Q is on y-axis and OQ is equal to 8 centimeter. So I told you before also that if you want to find the coordinate on x-axis, your y is absent, so y will be 0 and x will be 6. And if your point is on y-axis, your x is absent, so 0, 8. Alright, so you have two coordinates. I've used the distance formula here. Just check it out. Okay, coming to the next question. I'm reading the third one. Prove that the distance between A 1 2 and B 3 8 is double the distance of C 3 minus 1 from the origin. So we need to prove that the distance between this A and this B is double the distance of C and the origin. Okay, so given that A 1 2 and B 3 8, let us first calculate AB. So AB will be x2 minus x1 the whole square plus y2 minus y1 the whole square. This is 2, this is 6, 2 square plus 6 square, 40. 40 can be solved as 2 root 10. Okay, 40 can be written as 4 into 10. 4 is taken out as 2 and root of 10. Now distance between the point C and origin CO I'm taking, that is 0 0, its coordinate will be 0 0. Alright, so CO will be, OC will be x2 minus x1, x1 minus x2, both you can do, no problem. Okay, so y2 minus y1 or y1 minus y2 the whole square, you will get the same. So you will get root 10 with that. So as I see that this is 2 root 10, this is root 10, so AB is 2 root 10 and OC is root 10. So AB is equal to 2 times of OC, okay, because this is 2 root 10 and we need to multiply 2 to get 2 root 10 equal to 2 root 10, okay. So hence AB is double the distance of C from the origin, okay. Alright, now the next question, C1 I'm doing, third C1. Prove that the distance of the points A sine theta plus B cos theta and A cos theta minus B sine theta from the origin is independent of the value of theta. See, this coordinate is a one coordinate where x-axis is representing x-axis A sine theta plus B cos theta and y as A cos theta minus B sine theta. So distance from this point to origin is independent of the value of theta. That means when you solve and you get the answer by using the distance formula, your answer should not come in theta terms. Okay, so that is what we are going to prove. So this was the question. Distance between the 2 points will be x2 minus, from the distance between the 2 points, that means this point and 0 0, okay, 0 0 will be the other point because origin. So x2 minus x1 the whole square plus y2 minus y1 the whole square. We know this minus 0 will give you this only, so I'm rubbing this in this step only to make you understand, but you need to again write it by removing the 0, okay. So a plus b the whole square identity we will be going to use, so it will be a square sine square theta plus b square cos square theta plus 2ab sine theta cos theta, okay. 2 into this ab I'm writing close and sine theta cos theta here, plus a square cos square theta plus b square sine square theta minus 2 into a into b sine theta into cos theta again. Now as you can see that 2ab sine theta cos theta can be cancelled with this, then a square sine square theta plus a square cos square theta I'm writing close, then plus of b square sine square theta and plus of cos square theta, okay. Now from these two I'm taking a square common, so in the bracket sine square theta plus cos square theta. Among these two I'm taking b square common, sine square theta plus cos square theta. In the trigonometry we have seen one square relationship, that is sine square theta plus cos square theta equal to 1. So in place of this I have written 1 and this also 1. A square plus b square. So this value is independent of theta. Are we getting any theta here, sine theta or cos theta? No. So hence proved. Okay. Okay. Let us come to question number 4. See, in this fourth A and B you can easily do. Why? Because now you have to see, I'm reading fourth A. Find A if the distance of the point 4 1 from the point 3A is root 10. So you are given the distance and you need to find the value of A from it, so that we can do, let us do the similar one, that is C1. KM is a line segment of length 13 units. If K has coordinate 2 5 and M has coordinates x minus 7, then find the possible values of x. Okay, so you have a line KM. K is having the coordinates 2 5 and M is having the coordinate x and minus 7, and the distance between these 2 points they have given, that is 13 units. So we need to find the value of this x. So so here is the solution. Given Km will be what? X1 minus x2 the whole square plus y1 minus 7 the whole, that means 5 minus 7 the whole square. Now using the identity here, a square plus b square minus 2ab plus this will be minus plus, so 12 square. Now we need to remove this root, so we are squaring both the sides. Okay, squaring both the side, this 13 will be 169 square, 13 square is 169, it will be 4 plus x square minus 4x plus 144. 4 plus 144, 148. Take this 169 that side. So 148 minus 169, you will get minus of 21. Okay, so x square minus 4x minus 21 equal to 0. Now this is a quadratic equation. Okay, we know we have solved this such type of equations in the factorization chapter. Okay, we are splitting this minus 4 as minus 3x plus of 7x, because the factor of minus 21, 1 you will get minus 3 and 4 and minus 4 and 3. Okay, so 7 and minus of 3, sorry, not 4. So we'll split as minus 3x plus 7x. From these two, take an x common. From these two, 7, x minus 3 again, and x plus 7. Put 1 x plus 7 equal to 0 and x minus 3. You will get x values as minus 7 and 3. So all possible values of x they've told in the question. So that is why two values came. Okay. Okay, coming to the next question. Question number 5th B. Find the point on y-axis whose distance from 3, 2 and minus 1, 3 by 2 are in the ratio 2:1. So we need to find a point on y-axis. So if we want to find the point on y-axis, we need to take that point will be 0 and y, whose distance from these 2 points are in the ratio 2:1. So let us first calculate the distance between 0, y with this point and this point. So taking these 2 points first, so x1 minus x to the whole square plus y1 minus y to the whole square, this will give you 9, and opening this bracket will get this much. 9 plus 4 you will get 13 plus y square minus 4y. Keep it as it is. Now calculate the distance between this and this point. So 0 minus 1 whole square plus y minus 3 upon 2 the whole square. It will give you 1 only, and opening this bracket will get this, because y square plus 3 by 9 the whole square will get 9 by 4 minus 2 into y into 3 by 2. 2 to 2 cancel, 3y. So that is why we have written 3y there. So 1 plus 9 upon 4, you will get 13 upon 4 plus y square minus 3y. Now they are in the ratio 2:1. So this upon this will be equal to 2 upon 1. Okay. Now take this expression that side and this one here. So we'll get this step. Squaring both the side, because we need to remove the square root. So this will be here. This 2 will be 4. 2 square will be 4, and we have removed the root here. Now after this, I'll do from here. Okay, so I've copied this step here. Okay, multiply this 4 inside. So when you will multiply 4 to 4 will cancel. We'll get only 13. 4y square and minus of 12y. As we can see that this 13 with this 13 we can cancel. Take plus of y square that side and minus of 12y here. So minus 4y plus 12y equal to 4y square minus y square. It will be 8y, and this will be 3y square. Now take 8y here. So 3y square minus 8y equal to 0. Take y common. So 3y minus 8 will get equal to 0. So one y will be equal to 0 and another 3y minus 8. From there you will get y equal to 8 upon 3. So you got two values of y, and we have taken coordinate 0 y. Okay, so 0 0 will be one coordinate, and 0 8 upon 3 will be the another coordinate. So just do up to 5th question. I hope you have one Sunday also, it's coming. All right, so make use of it and do up to 5th question, and move ahead if you can solve some other questions also. Alright, just see the examples, do the practice. Okay, thank you so much. Have a nice day. Bye bye.